Good afternoon.
Good afternoon.
Good afternoon.
How's everyone doing today?
All right. Just tired.
Sorry to hear that. Kind of chilly out there, isn't it? All right. Okay. One more. Okay, good. Okay. Yes, the Wi-Fi must be fixed in your dorm rooms. Okay, good. All right, so we need to continue with what we were doing. We were doing review. Got one more here. Okay. Okay, I'm going to go ahead and share my screen. Okay, so we were in the middle of looking at a review. Okay. Let's see. And I've been posting the lectures up here. So in case you missed anything, when you see lecture and the date, that's what it is, okay? I'm recording these so that you guys can have them, put them on YouTube and just post the link. All right, so this is where we are now on Vesper. We were looking at Lewis structures. And I told you about intermolecular forces and Lewis structures, and that lecture is not on here yet. Oh yeah, there it is. Never mind, it is here. Okay, so I think when it's blue, when it's black, it doesn't work. No, it worked. No, see, it doesn't. And that's because I need to do something else. Okay. So I'm gonna fix that afterwards, but as you know, they're all here. So, all right. So there are some assignments. So let me go back to the modules so I can show you. Okay. So right now, we have this is where we are right here. Like I said, I'm going to fix this and put it under here. But the one that says class practice is class practice, but the one below is your homework. So I haven't opened it yet because we haven't covered it yet. Now these other ones, as you can see, they are covered and they were due January 16th. If you missed them, you need to let me know now so I can extend it. I would only extend it like until the next class period. So Monday. No, Tuesday, sorry. Okay, so let's look at the class practice. And we're gonna download it so that we can actually look at it. All right, this is a big, long one, so I'm not gonna do all of them. Obviously, we're just gonna go ahead, sorry. I don't know why this came up. Okay, we're just gonna go ahead and do a couple of these, following the rules and the step by step. And don't forget, this is very important, this one chart here is very, very important. I'm seeing that I'm missing some stuff like 180 over here, and this would be 10. Well, these are all 109.5, but when they're separate, they're actually, this would be 109.5, this one would be 104.5, and 107, sorry, and this one would be 104.5. So they are different, but it's okay. And they're not all exact either. So that's probably why they're there. Okay. So the very first thing to do is this. We are looking at everything that we looked at already, but we are also going to add the intermolecular forces that we haven't done yet. Okay, so let's look at our first one. Notice that our first one right here is CCl4. It's already done for us. And the polar, non-polar, and then we don't have the intermolecular forces, which we are going to put in here. Okay, hold on, let me enable editing, otherwise it will not let me. Okay, of course, sorry, there we go. All right, so the intermolecular forces go here too. And in this case, it's just London dispersion forces because it is non-polar, it is not charged, it doesn't have anything else that it could be. So it's just London. All right. The next one is, I'm going to skip to SO3. We did this one yesterday. I don't know if you remember, just a plain SO3. So what we're going to do is we're going to do these calculations. Well, I'm going to do the calculations directly on here. But the Lewis structure, I can't put it in this little thing. So I'm going to draw it to the side and then you can draw it in if you need to. All right, so in this case, we have one sulfur, right? And it is on group 6. And then we have 3 oxygens. And they're also in group 6. So that gives us a total of 18 plus 6 is 24, right? All right, now, when we do the crude sketch, that's what the next part is. We're going to use our drawing. We know that the sulfur is the middle one because there's only one of them. And we've got 2 oxygens, right? So we need to draw the oxygens. So this is our crude sketch. That was what would go right here on this, right there. Okay. Now the Lewis structure we haven't determined yet, but the next part would be to now take what we know, which is we have 24, right? But we used 2, 4, 6, so 2 per bond. So basically what this is doing is saying we have 3, right, times 2. That's what we're subtracting, so it's 6. And that gives us 18. So 18 left over, it's not going to be sufficient to go around all of these. We can do that, and I know that already, but that's me because I have experience. But if we count them, that's 6. That's another 6, and this one's going to be hard to put it on, but I think I can manage. Yeah, there we go. And that's another 6. That's our 18. Sulfur is not an exception, so it's going, well, what happened to mine? So what we're going to do is we're going to take this pair right here, doesn't matter which pair we choose, and we're going to pass it to the middle area. See, and that makes a double bond. And that's our Lewis structure. Because we had no more electrons, we cannot add lone pairs down here to the sulfur. So what we need to do is we need to move one of our existing lone pairs on one of the oxygens and make a double bond. So that right there goes here, right? That's our Lewis structure. Now the next question is, how many electron groups do we have? Okay, we have 3, right? Because groups are the regions of electron density. So that would be here, here, and here. That's 3. Which means that this original shape would be trigonal planar. Based on your, if you're looking at your a chart that I showed you earlier, if you're looking at that, that's what it would say. The next question that we have is how many of these are bonded atoms? And let me just clear this stuff. Okay, how many of these are bonded atoms? Okay, bonded atoms, we have 3, right? So once again, we still have a trigonal planar. Do we have resonance? Well, let's redo that structure that I shouldn't have erased. But okay, so we had this going double, this one single, this one single. So yes, we do have resonance structures because this double bond that exists right here can be moved, and I'm going to move it over here. That's why I'm already moving the lone pairs. So we are going to move this one, and we're going to put it here. And this one's still the same, so we are now going to do those. Yes, that is one other structure. There is one more structure that we could have, and that would be taking the lone pairs from here, right? Putting back this guy, and now moving them off of this one and putting a double bond there. So there are a total of 3 resonance structures. So we're going to write down 3 on there. That's all we need to do. Just, they don't fit here. So I did kind of leave you enough room so that you could just do them in there, the extra 2. But if there isn't enough room, by you putting 3, you should know that they're moving around on the 3 different bonds. Okay, so that's that. Now, the question is it polar or non-polar? Remember what I told you? What matters here is that we do not have lone pairs around the central atom, and we do not. So it is a non-polar. Once again, this is a London dispersion force only because all we have is a molecule that is non-polar. So the only thing it can actually do is that, as far as forces go. Now, the next one that we have is ClO2 negative. Let's do that one. Okay, I'm skipping around every other. I'll let you guys do the other ones if you want. Okay, so we have 1 chlorine, and he is in group 7, right? He, she, whatever. And we have 2 oxygens in group 6. Plus, we also have 1 more for the charge. That's a total of 8 and 12. That's 20, right? Am I correct? You guys need to add with me because I'm doing this just thinking about it. Okay, so the next thing to do is to draw our crude sketch. We know that chlorine has to be in the middle because there's only 1 of them. And then your oxygens have to go around. So that made 2 bonds. Okay, so our next thing is to do is to take those 18 that we had. Oops, not there, sorry. Those 20 that we had. And subtract 2 times 2, right? Because for each one of those, we have 2 electrons used for every bond. And there are 2 bonds, so that makes it 4, gives us 16. All right, we know that chlorine needs all 8. We know that oxygen also needs all 8. So what are we going to do? Let's see, we only have 16 to go. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's perfect. Now, the last thing, since it is this kind of molecule that is charged, we need to label the charge and put brackets around it. Okay, so that is what goes here in this area right there. All right, next thing, oh, sorry, in this area right here. I'm looking at the wrong one, sorry. Next thing to do is how many electron groups do we have around the central atom? So we have, I'm going to circle them. We have this one. That's a group. We have this group. That's another group. We have this one. And we also have this one. So that makes it 4. So the answer here is 4. Okay, 4, and that makes it a tetrahedral. Now, how many bonded atoms do we have? In this case, we only have 2, right? And that is not about the same shape anymore. Now it's called bent. Now, do we have resonance structures? No, because we have no double bond, so we can't have resonance structures. Now let's look if it's polar or non-polar. We said that in order for it to be polar, it has to have lone pairs, right? So yes, it is polar. What else do we know? Well, all molecules have London dispersion forces. Anything that has polarity has dipole, and I'm just going to call it dp. This molecule is also charged, so it can have an ion dipole also. So that is all there is right there. No hydrogen bond because there is no hydrogens. So that's it. Those are all our forces. Now, the one thing I don't see on here that we could be speaking of is our angle. And let's add that just over here somewhere, just under the tetrahedral part. Okay, so for this particular one, our bond angle would be 109.5, okay? For this one, trigonal planar, it would be 120. For this one also would be 109.5. One of the things that I covered is that when you have a lone pair and it actually makes more of a repulsion force towards the other electron groups. So that makes it constrict these bonds. Okay, see, now we're going to talk about this one. So far they've been non-polar, therefore the bond angle stays the same. But in this case is 104.5. And like I said, it varies, but the general is 104.5. All right, so that's that page. Now let's look at this next page. We have water, and we have SO4, NO2, PO4, NO3. Which one do you want me to start with? And H2O or SO4? I'm sorry? Or you can just chat it. It's fine. And do the chat. That's what I usually do. I look at the, oops, sorry. I look at the chat while I'm doing this on the side. Okay, SO4 -2. Okay, we'll start with that one. All right, so we're not doing the crude sketch yet because we got to do calculations first. That's always the first thing. Well, actually, if you think about it, yes, you could do the crude sketch first because you already know that your central atom is the sulfur, right? So we can do that. We can do the crude sketch. Central atom, 4 oxygens around it, right? And that's our crude. We don't know anything else. That's why it's called crude, is because we don't have any idea except for the positioning of the atoms. We cannot say they're double bonds, single bonds, what's going on, nothing. We do not know until we do our calculations. So we got 1 sulfur times 6 because we have 6 electrons on that one. And we have 4 oxygens, also times 6 because it is in group 6. And we also have, oops, we also have 2 extra electrons because we have a negative charge. So that gives us 64, 32, right? Yeah, that's 32, I think. That's what I get anyway. All right, now, since we have our crude sketch, we can say we have 32 minus, we have 4 bonds, right? Times 2, so that's 8. 32 minus 8 is going to be equal, oops, is equal to, oh Lord, can't type today, is equal to 24, correct? All right, so that's how many electrons we have left. Now, the next thing to do is to distribute them. Remember, this is step 1, step 2, this is step 3 right here. We need to distribute the 24 electrons that we have in all of these. And this is the official Lewis structure. Now, if you look it up, it's going to give you a double bond somewhere. And the reason that is after you do 4 more charges, but we haven't learned 4 more charges, so we're not doing those right now. We're just looking at the shape, and the shape is going to remain the same. All right, so when we look at that, that is all 24. We just used them. And everybody's got 8, so they're all perfectly fine. Last thing we need to do is to put our bracket, right? Don't forget that in your -2. All right, so our Lewis structure, that would go there, right here. This is where this would go, right, in this area. Now, let's look at the number of electron groups. All right, electron groups, we have 4, right? And that makes it tetrahedral. And that angle, let's add angles, it's 109.5. Number of bonded atoms, still 4, because there are 4 oxygens bonded to the central atom. That's tetrahedral, right? And that angle, again, is 109.5. So this, are there resonance structures? None that we can see, because there's no double bonds. And is it polar? The answer is non-polar, right? Because we do not have lone pairs around the central atom. Now, that makes this have London dispersion forces because everybody that is non-polar and polar has them. The other thing we know is that it could have an ion dipole. An ion dipole. And that is about it because there is nothing else that it can do. All right, because it can induce an ion dipole on something that has a dipole itself, because it is an ion, right? So that's why we're calling it that. All right, next one is PO4 3 negative. All right, let's do that one. All right, let's do, and this is actually going to be a very easy way of doing it. I'm just going to go ahead and erase some of these and just We'll redo that part, but right now I just, okay, so the middle one is a P. We know that. All right, so we'll do the P there, and that's our crude sketch. All right, so now we need to do our calculations. We have one phosphorus, and that is, I'm not mistaken, is in group 5, right? So that makes it 5. Then we have 4 oxygens, right? In group 6, plus we have 3 extra electrons. So when we add these, we get 24 plus 8, basically, right? And that gives us 32. So you notice it's the same as this one. That's why I knew that was going to happen. So I just kind of put it there myself and left it there. All right, so we have 32 electrons, and we have the same thing going on here. We have 4 bonds, each one taking up 2 electrons. So the total is going to be 24. That's all that's left. And what we need to do now is draw our dots. And remember, the dots are placed in such a way that they are 2 on each side, as if you had a box on top of it. It's kind of hard to do it with the way I'm doing it, but I'm trying to make them as right as possible. Okay. Now, one thing left to do is our bracket and labeling the charge, which is -3. All right. That is the Lewis structure that goes here. Obviously, we can just pretty much copy everything that we've done so far, right? Because it is tetrahedral, it has 4. All of this can be copied and put here because it is right. And then there are no resonance because we do not have double bonds. And once again, this is all true. All of this right here can be copied and put on there because it is all the same. All right, so those are the 2 that I'm doing on this one. What about the next page? All right, let's start with CO3, 2 negative. All right, let me clear all of this and start with that one. Okay, CO3, 2 negative. All right, crude sketch. Well, we have 1 carbon, right, in the middle. You guys should be doing this along with me before I say anything. You should kind of be going, you know, so that way you can get used to what to do. And there are 3 oxygens that go around. That's your crude sketch. All right, now let's do the calculations. This is where you need to start looking at your periodic table. We have 1 carbon in group 4, plus we have 3 oxygens, right, in group 6, plus we also have a charge of 2. So that's going to give us an answer of what? 18 plus 6, right? So that is 24, correct? All right, now let's do the rest. Okay, we have 24 electrons. We're subtracting 3 times 2, which is 6, right? And that gives us a total of 18, correct? All right. We have 18 electrons to place around the outer atoms. And that is not going to be enough for carbon because carbon is also not an exception. I can tell you just by looking at this. 6 times 3 is 18, and each one of these oxygens need 6 because I already have 2. Now carbon's going, wait a minute, where's mine? Again, so we need to remove one of these and put a double bond. And that right there fulfills it. Now, another trick that you can use to make sure that your Lewis structure is sound is count how many actual electrons you used, and you started off with 24. So let's see, 1, 2, so that's, we're counting pairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, times 2, 24. So that's good. We know we did good. All right, so next thing to do, last, is to put our -2, because this is the carbonate ion. All right, what do we see? And the Lewis structure, like I said, goes there. What we see here is we have 3 electron groups, right? That's all I see, which makes this a trigonal planar. And this is pretty much the same, so I'm just going to copy. Hasn't changed. One thing we haven't done here is put our bond angle, which is 120 degrees. And of course, here is also 120 degrees. Do we have resonance structures? Yes, we do. We have 3, because that double bond can go here, right? Let's see, hold on, it can go, I'm gonna spotlight it. It can go here. Come on, spotlight. It can go here. Can we see the spotlight over here? Right? Or it can go here. All right, so we do have 3 places where that can go. So next we have our last few things to answer. Is it polar or non-polar? You tell me. You can put it through the, okay, how about we do it like this? If it's polar, hold on. I have to see you first. Okay. People, where are you? Participants. Come on. Why is it not doing what I wanted to do? There we go. All right. If it's polar, put a thumbs up. If it's non-polar, what else is there? Thumbs down. Is there a thumbs down? You're not doing it. Okay, there we go. Thumbs down. Yep, you would be correct. Yep, yep, definitely. It's non-polar. Why is it non-polar? Because there are no lone pairs around the central atom. So it's non-polar, which means, once again, that this can have London dispersion forces, and it can also have ion dipole because it is a charged molecule. All right, and that's that. Next one we're doing is NO2 negative. Right, oops. Actually, SO2 is a really interesting one. You guys should do it while I'm doing mine. I'll let you guys do that one, and I'll do NO2 negative. You do SO2, see what you get. Okay. I'm not talking so you can concentrate. Okay, what did you get for SO2? What was your total electrons that you had left? Mhm. Okay. It was the same as mine, right? Because you actually have an extra electron on sulfur, but you do not have a charge, but that's okay. Now, let's look at what we have here. We have 3 groups, right? So that electron group geometry is trigonal-planar. Oh, where's my P? All right, and then this is 120 degrees. Now, the non-bonded atoms is only 2. And this is a bent structure, which makes it less than 120. We don't know how much less. It just depends on what's bonded to it, to the central atom. But it kind of makes it that. Right, do we have resonance structures? Yes, we do. We have 2, right? And is it polar or non-polar? You tell me. Is it polar or non-polar? Same way. Thumbs up if it's polar, thumbs down if it's non-polar. Very good. You are correct. It is polar. Now we have a whole other set of, things to add here. We have ion dipole too, right? Because we have a charged molecule. We also have dipole-dipole, but we do not have any hydrogen, so no hydrogen bonding. All right, that was that one. Next one that we have is I4. Let's clear those. I'm doing these, quite a few of them, because they're all different and they all have something interesting about them. And I just want to make sure that you guys know what to look at. Right, so Si4. We have silicon in the middle. And we have 4 iodines on the outside. That's your crude sketch. Yeah, it's going to look like an ion, but that's all right. All right, so for this, we have silicon. One of those is in group 4, no? And then we have 4 iodines in group 7. We have no charges, so that's the answer right there. So we have a 32 total, right? Because it's 28 plus 30 plus 4 is 32. Right now, out of those 32, we used 4 bonds times 2, so that's 8. That's going to give us 18, right? I mean, 19, sorry, 24. I don't know what I'm thinking. 24, if we take 8 from 32. Okay, so we need to now put little dots around it. That's 6. That's 12. That's 18. And that makes it 24. And silicon's fine because it has 4 around it. Everybody has 8, they're good. All right. Like I said, that Lewis structure goes there. And now what is next? We have the number of electron groups, okay? In this case, we have 4 of them. That makes it tetrahedral. And that gives us a bond angle of 109.5. Nothing changes for the other one because we have no lone pairs. So tetrahedral again, and 109.5 again. No resonance because we have no double bonds to resonate. And is it polar or non-polar? Once again, polar thumbs up, non-polar thumbs down. Okay. All right, excellent. So it is non-polar again, and that is the correct answer because it has no lone pairs in the central atom. Therefore, we are limited to London dispersion forces because we're not even charged. So that's all we have. Now let's go and our last page. And that page, I want you guys to do yourselves. You want to get into a room and do groups? I will put you in separate rooms. Let me do, oh, let's see, 1, 2, 3, 4, 5. I'm gonna put you in 4 rooms and I'm gonna let you do the first 4, each one of you, so that the first one's gonna be group 1, like NH3, right? That's group 1, H3O plus group 2, NH4 plus group 3, SO3 2 group 4, and then everybody does CHCl3. All right, so I'm going to do that right now. I'll have to stop sharing. So you guys got your assignments? Think about it. Those are the ones that we're needing. So I'll let you know which ones you're doing. All right, so I'm going to close this off. Stop sharing because otherwise I can't do the, yeah, see, I cannot. I cannot do it unless I stop sharing. Cannot do the grouping. All right, so I'm going to do that. Put you in breakout rooms. 4 of them. Create. All right. Wherever your name is, go to that room. Okay. Okay, everyone. We are ammonia or NH3, right? And CH3Cl. No, CHCl3, sorry. So that's the 3 that you have, the 2 that you have to do. And then one of you pick which representative is going to give you the ones, you know, the report, basically. Who's gonna, okay? All right. That's all I had to say to you, and I will see you in a minute. And if you need questions, you can call me in, but I'm going to be in another one right now. Okay, hello everyone. In case you don't remember, you have H3O plus and CHCl3. Got that? All right. If you need me, like if you hit a wall or whatever, I'll come and see you if you call me in. All right. Okay, I'm gonna leave this room and go to the next room. Corey and everyone else, that I am in breakout room 3 now, and that you are doing NH4 plus, and you're also doing CHCl3.
Like, can you say that again? I didn't hear you.
I said NH4 plus, right? That's the ones that you're doing. And CHCl3.
Can you type that in the chat, please?
Sure. It won't look like it's supposed to, but I can.
Okay.
All right, so, oh, in the chat, I'm gonna just type it directly to you, Corey, and you can share with everybody.
Okay.
Because I can, or Diamond, or somebody, the first person I see that is in that room.
And are we on the balancing chemical equations homework worksheet?
Yes, the other one's the work. Yeah, the other one's the actual homework.
Okay.
So you got NH4 plus. Like I said, it's not gonna look like it's supposed to, because in the chat I can't do subscripts and superscripts, but you get the idea, right?
Yes.
Okay. All right, there you go.
Thank you.
Mm-hmm. And you choose one of you, probably you, Corey, representative that will tell everybody what you did at the end. Okay.
Yes.
All righty.
Mm-hmm.
I'm leaving this one and going to the next one.
All right.
Okay, bye. Everyone. Okay, you had SO3 2 negative and CHCl3. In case you don't remember, I'm gonna put it in the chat if you need me to. Let's see, I'm gonna do you, Delisha. So it's SO3, and it's not gonna look like it's supposed to because I can't do the, it'll look like 32 negative, but it's SO3 2 negative, but I can't do subscripts and superscripts in the chat. So, and then the other one is CHCl3. Okay, there you go. And one of you is going to tell the rest of the class your answers. So be prepared. Okay. Okay. Thank you. You're welcome. And you can call me at any time if you hit a snag or whatever, and I'm gonna go back to the waiting room.
Okay.
All righty. Yeah, so no need. Does not have any resonance structures, does it? Yep, nope. Okay. 11, right? Yes?
Hi. Okay. So for CH3, CHCl3, right?
I'm
How
sorry?
would for CHCl3,
Uh-huh.
how will we go about doing that since carbon and hydrogen
Okay,
is
yeah, I know that was a curve I threw you in there. That's why I'm making everybody else do it. See if anybody else can figure it out. Okay, so you still got to do your math like normal, right? So you got one carbon, and that's 4. One hydrogen, that's 1. And 3 chlorines, that's 21. So
Yeah.
you've got 21 plus 1 plus, what did I say, 4? So that's a total of 26, correct?
Yeah, correct.
Okay, so now you're going to subtract 8 because you
26
have 8
minus.
total bonds, right? So that's going to give you 18.
Oh,
18
okay.
electrons around, because carbon's got enough. Carbon has 4 bonds, it's fine. So now you've got 1 hydrogen and 3 chlorines. And you know, the funny thing is
Right.
hydrogen doesn't need but 1, right? We already know that.
Yeah.
So it doesn't need any more. So chlorines are the ones that are going to get all these dots. The 18 dots go to chlorine, 6 each, right?
Yeah.
So if you look at the shape, it's a tetrahedral
Yeah.
because there's 4 groups around the central atom. The molecular and the actual shape is a tetrahedral, but there's a part, and I'm going to share my screen and I'm going to let you read something of here, and you'll determine the rest from there. Okay. Hold on, I'm getting there. It's taking too long though. There we go. Right here where it says polarity. Read that part. So now you know the answer, right?
Yeah.
Okay, I'm gonna go share this with the other ones because I was gonna let them struggle for a minute and just think about it. That's how you learn. I'm not being
Yeah.
mean. I'm
Yeah.
not being mean. That's just how you learn. Okay,
Okay. Thank you.
you're welcome. Okay, stop sharing that. Just making sure you guys got the message I just sent on the chat. That should help you with that. Determining polarity. Okay. Guys are too quiet. Supposed to be chatting. Okay, so I sent you a piece of information that might be helpful via chat. I don't know if you saw it yet. Make sure you read that and figure out that last piece. Okay, I was just coming in to let you know that I sent a piece of information that will be helpful for you determining polarity. If you read it, you should have the answer. Okay, that's all I needed to say.
Where did you send it to?
Oh, via the chat?
What chat? I don't see it.
The chat? Can you see that?
The last chat that I see from you is when you wrote NH4 positive CHCl3.
Oh, really? Huh, because I
Yeah.
sent it to everyone.
No, that's all I see in the chat.
Huh, okay, hold on. Let me do another. This is weird. It should have worked because it says to everyone.
My friend, she right here, sitting next to me. She didn't get it either, and she in that other group with AJ and Jackie, whatever that name is.
Yes, gotcha. I understand. Okay, I'll resend it.
Okay.
I'll resend it so that you can get it. Let me see how I'm going to do that. Apparently, this is not the way. So I'm going to check, make sure I know how to do this. There's got to be. Did you get it that time?
No, I didn't get nothing.
Okay, it was a broadcast to all, and I did it, and it says it did. Oh man, this is annoying. Hold on, I'm gonna do it again. Oh, it's not all of it. Hold on, I gotta go recopy it. Oh Lordy, hold on. Excuse me. Oh, what it is not letting me put the whole message in.
Oh, okay.
It's not because it's too long.
Yeah. It's not showing.
Yeah, but I can put the second half now that I know where it stopped. And
But the other part went away.
I'm sorry. I'm just gonna get the little bit. How about that? I'll just put the most important. Oops, sorry. Oh, my throat got really dry there. Okay, do it again. All right, now you should see that. Can you see it?
Yes, I could see it.
Okay, good. That's what I meant to do. I thought that by doing it, from the other.
So I'm still a little lost over here.
Okay.
Okay, so are we working on the balancing chemicals equation homework?
No, you're working on those two things I sent you.
Oh,
What we were doing, the same thing. Just gotta do the Lewis structures of it. There's nothing
oh,
to balance. It's all Lewis structures. Yes, what we've been doing all along.
my bad. I was a little hard of hearing because of the area that I was at the moment.
Okay, well, that's what we're doing. We're doing the, just the Lewis structures. Every part that we did, you did the Lewis, you did the crude sketch, you did the Lewis structure, the calculations for the numbers, the electrons. Then you did figured out what shape, what molecular shape, what electron group geometry it had, the angle, whether it was polar or non-polar. That's basically it, and what forces. So it's quite a bit of stuff. That's why I only gave you two, because we're
Okay.
about to have to close here in a minute. So you might want to keep working, because I'm going to close at, I was supposed to close at 4:10 and I'm already past it, but I'm going to give you guys a little bit longer. I'm going to give you till 4:15. So that's 2 more
Okay.
minutes. All right.
Okay.
Okay. Bye-bye. Okay. Okay. hopefully everybody has answers. Let me share my screen again and we're gonna put them in. All right, I need a representative from group 1 to share their answers, either via the chat or you can actually speak. Sorry, I had the wrong thing up there. Okay, there we go. All right. Okay, group 1. What did you find out about NH3? After you did your calculations and all of that, what was what was your electron groups? Okay, 8 valence electrons total. Okay, so that's good. What else? I know the Lewis structure is impossible to do here, but you can tell me about what was your electron groups? How many did you have? 4, which made it what kind of shape? And as far as bonded atoms, how many did you have? And that made it what kind of shape? Correct. Very good. Now, did we have resonance? Okay. What about, was it polar, non-polar? Yes, definitely. Oops, where's my O? And what were the forces that you see in this one? Okay, well, you have London dispersion always. Dipole, dipole, because it is polar, right? It is a charged molecule. No, it's not. So, but since it is polar, it could induce an ion dipole with an ion, but we're not going to call that one. And we also have hydrogen bonds, and that is correct. All right, excellent. So basically pretty much done. All right, what about the other one? What did you guys get? As far as how many electron groups in the calculations? The CH3CH, Cl3, sorry, CHCl3. I always say CH3Cl, it's backwards. You guys get it? (26), okay. 26 valence electrons, that is correct. And you ended up with, since you had all of your 4 that you, your 4 that you had to subtract from there, you ended up with 18, right? Yeah, 4 electron groups, okay. That is correct. So that makes it tetrahedral, right? And how many bonded atoms? Yes, and that made it tetrahedral also. Oops. Okay, no resonance that you can see. Obviously, there's no double bonds. What about polarity? What did you find? Polar or non-polar? Okay, you said polar, which make it London dispersion, right? And dipole only, because it's not charged. Okay, that's group one. All right. Thank you, ma'am. You guys did great. All right, I need group two. They had H3O plus. Group two. Okay. Thank you, Karen. All right, what is your calculation say? How many electrons? Eight, you think? Eight, you're right. You're correct. It is eight because you have three, right? Times one, well, or yeah, because one hydrogen, three hydrogens, plus you have one times six, but then you have to subtract one because, oops, that's a one supposedly. What the heck happened there? Okay, there we go. And that gives you eight. That's correct. Oops, gives you eight. And then from there, you have to subtract, right? Three of them, so six, 3 times 2. Oops. It didn't stay long enough. Okay, so that gave you only 2. Yes. Okay. So what were your, how many electron groups did you have? 4. You know why 4? Because when you have that extra lone pair, it has to go around your central atom. And that would make it look like this. Okay. Okay, so hydrogen, 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 and you would have to have a lone pair down here, right? All right, so that would make it 4. All right, perfect. Next would be the shape, which we know is tetrahedral because we have 4. Now, how many bonded atoms? Now you can say the different number, right? It's okay, baby. It's all right. I have my kitty here. It's okay. What's your matter? You missing now? All right, 3. And that would make it a trigonal pyramid, right? Now, is that making it polar or non-polar? Oh, first of all, no resonance. We know that because there's no double bonds. But polar or non-polar? What did you have? Waiting. Not giving you this answer until you give it to me. Polar. You're correct. Now, what forces? Yes, definitely dipole, dipole. What else? Yep, definitely London dispersion because everybody has those. There's more. Hydrogen bonding, yes, very good. And one more. Because it is charged, right? So then we have one more force. And that would be? Okay, ion dipole, yeah, okay. All right, now, oops, what was that? For this last one, what did you guys get on this one? And we're just gonna write everybody's answer. So did you get, it was polar or non-polar? See, you notice I'm not even saying yes or no to either one. I'm just asking you. What did you get for the second molecule? Polar also, okay. And what were your forces? Yes. And dipole, dipole, okay. Anything else? All right. Group 3, where's yours? Oops. All right. I need somebody to come forward for group 3, please. Okay. Nobody? Need more time? All right, let's do group 4 first. All right, group 4. What do you have? Delisha, I think it was you that was going to give me the answer, right? Okay. So what were your calculations? How many electrons did you end up with? 26. Okay, that is correct. All right. And then you took away, yep, so you ended up with 20. So I'm just going to put them down here. We'll fill it in later. All right, very good. That gave you what kind of electron group geometry? 3 electron groups, okay. So that was trigonal planar, very good. And then you had resonance, okay. But we still have bonded atoms, so that was the same, right? 3, and according to you, that was 3 in trigonal planar here too. And you said resonance, you have 3. Okay. Oops, sorry, wrong place. 3. And here you have polar or non-polar. Polar. Something's interesting here. Okay. And you have what were your forces? Yes, no doubt. Dipole, dipole. And more. Yes. If it's polar, yes, because it is charged, it's iron dipole. Okay. All right, group 3, are you guys ready? Oh, and oh, sorry. Nope, not yet. We still have one more. You need to give me, I'm going to give them the space and then let you tell me this last one. Was it polar or non-polar? For the second molecule, Alicia. Polar, okay. Yes, they aren't identical. You're right. That is a very good idea on that one. Obviously, London dispersion as everybody. So what else if it's polar? What else would we have? Yes, dipole. Dipole. It is not charged, so not ion dipole. I don't think that would come into play in this one. All right, group 3. I'm still waiting for yours. Thank you, Alicia. Come on, group 3. All right, so I'm gonna do the math on this one since we have, okay. Thank you, Corey. I am waiting. I'm gonna do this math on these. I forgot what I'm looking at. NH, what is it? SO3. Okay, so 1 sulfur times 6 plus 3 oxygens times 6 plus 2 more for the bond for the charge gives me 26. And that is correct. And then here you have 26 minus 3 times 2, right? That gives you 20. So that's all correct. The one thing I don't see is why these two are the same. There's got to be something off. And let's look at what that is while we get this other group ready. Okay, so let's look. So we had a sulfur right in the middle. We had oxygen, oxygen, oxygen. So that's good so far. All right, we ended up with 20, right? That's 6. Aha. All right, excellent. Thank you. All right. I'm just doing this one for now while we wait. Okay. So that's 18. The 20th should be here. Right? 19 and 20. Now, that corrects this area right here into being tetrahedral, right? And that is not trigonoplanar, but trigonopyramid. And that should be 4 up here. Okay, now it makes sense. And there should be 0 resonance because you don't have double bond. Okay, so I'm just correcting that one. The rest I'm not correcting yet. Okay, so you've got the NH4. Okay, let's write it down. Yep, you got 1 times, oh, so yeah, 1 times 5 because you got 1 nitrogen, right? And you've got plus 4 times 1. And then you've got minus 1 because you have a positive. You're correct on that. And that gives you, okay, that's fine. You go ahead. Go ahead, Albert. You can leave. It's good. But you get the gist of it, right? So we'll be doing a little bit more of grouping if we keep going this way, because it helps you guys practice, not just listen to me talk. And yes, I can do this all day, but until you actually do it, you won't get it. And that's the point. And it's okay to make mistakes. Nobody's judging you. We're all here to learn. So if they're judging you, they're silly, because they probably make mistakes at some point too. So don't worry about that. That is not the problem. All right, so this gave us 8, right? All right, that's what you put on there. Okay, so how many groups, electron groups, Corey? 4, okay. Oops, not 5. And that makes it what shape? Oh, diamond. Thank you, Diamond, for taking over. Tito. Shh. He's very insistent. It's okay. Tetrahedral, very good. And that was how many bonded atoms? 3. Okay. Okay. And that make it what kind of trigonal pyramid? All right. And that no resonance, right? And polar or non-polar? Non-polar, okay. Which means that you have what forces? Okay. I'm waiting on your forces. Yes, LDF always. Yes. And then one more. At least that we know. No, no dipole since it is not, but ion dipole. Yes, because we have a charged molecule, right? Okay. So let me show you one more. Oh, and oh, no, never mind. Not yet. Okay, what about the other molecule? All right, did you find out it was polar or non-polar? Okay. Well, we're doing the second molecule that I gave you, the CHCl3. So what did you find? As far as polar or non-polar? Polar. Okay, thank you. And what were your forces? Okay, dipole, dipole, yes, definitely. What else? Anything else? There's another force always for everybody. Yes. Okay, good. All right, so you notice that all of you concurred on that last molecule, and you are all correct, by the way. So that was a good job. Once I gave you that piece of information, it made it easy, right? Oh, I just had asked the same thing Diamond gave me, so that's good. Your group came through. All right, so I'm trying to put it all up here, but it won't let me. And let's see, maybe if I get rid of this one. Ah, there we go. There. So as you can see, everybody has the same answers pretty much, which is good. Now, as far as the groups, this one is impossible for it to be like that, right? Because you have an NH4 plus, so you have 4 bonded atoms, obviously, because you got NH4, right? 4 of them, and then you got the plus, right? So that's your actual Lewis structure. So here we need to correct one thing, and then we'll be done. Here we need to correct. And you notice that you said nonpolar, so you knew that part was right. This is what's wrong right here. This can't be trigonal pyramid because you have 4. So it has to be tetrahedral again. And there you go. And everything else is correct. The only thing on this one, and you would think, oh, did we need hydrogen bonds? No, because the molecule is non-polar. So therefore, even though it does have hydrogen bond, there is no hydrogen bonding, but there is ion dipole. Okay, and that's it. We are done for the day. And we will meet again next Tuesday. Well, take care and have a great weekend. Thank you. Bye-bye.